liquid crystal display known as LCD 16:2 to display informations. Here we have the I2C converter to make it accessible to the controller, the header pins in which we are going to attach to the LCD to be able to connect the I2C to the LCD. We have the buck converter. We need lower voltage. We use this to step down bigger voltage. Here we have the Vero board for soldering, USB camera module or camera device for the Raspberry camera. Here we have the speaker cable for external connections like power and so on. Here this is the 5V power supply SMPS that converts this 240 volt AC to 5V DC. The Node MCU, the brain of the project, is a Wi-Fi enabled module that will be doing all the processing. Here we have the 4-channel relay that will be switching on and off our appliances. We have the jumper wires to connect to the Node MCU and to other peripherals. We have a terminal block where the appliances and the home will be connected. We have the HDMI cable with micro C, which will be connected to the Raspberry Pi to be able to program it via a monitor screen to be able to set it up for our project. It's very useful. We have the mouse, which is going to be used for the setup of the Raspberry Pi. We also have the keyboard for the setup of the Raspberry Pi. We have the scissors for cutting of wires and cables, soldering iron for soldering to the Vero board. And let's kick on. So here we have the LCD. We are going to be soldering the LCD to the header pin to enable us to connect the I2C to it, for us to see the information going on the project. And the I2C makes it easier. Instead of 16 pin of the LCD, we use 4 pin. Next, we also need the header pin for the microcontroller to be soldered to the Vero board for the connections. So we are using the double mount micro header for the microcontroller. We are positioning it perfectly on the breadboard, the Vero board, as you can see. Now it's time for soldering. So we want to solder some parts down so we can remove the microcontroller because the heat can damage it. So just solder some parts of the header pins with the microcontroller attached. Now we have finally soldered everything, so we can attach the microcontroller back again. As you can see there on the screen, perfectly fit. So it's detachable. Instead of being fixed on the Vero board, you can change it anytime you want. All right, next up is the 4-channel relay. We have the place to put the wires, the cables for the appliances. So we're going to be inserting them into those holes, as you can see, as I'm doing right now. So then you have to screw it down. Do the same for all other slots also. Now here's the finished version, connecting all the wires, appliances, the red for the live and the black for the appliances. Now we want to connect the power section for our connection. So you can see we have 2 header pins that are connected, and we have a male header pin for another type of connection. If we're not using the female, so you can either connect the appliances via the channel relay, as you can see. So we'll connect the jumper cables, the female to female jumper cables, since we have the pin type of connection. So now we've connected the jumper cable to the Arduino, to the microcontroller, MCU, Node MCU, and relay. You can see the pins connection. Next up, now you can see the pin connection on the Node MCU we are using, D5, D6, D7, the ground and voltage. Now to connect the LCD, so connecting the jumper cables to the ports. Instead of using 16 terminals, we are using 4 terminals now. So as you can see, now we are connecting it to the Node MCU. Now we can control it on the app. So you can see testing it as we are pressing the buttons, the relays are turning on and off. Amazing. Now we can also test it again using the power bank. You can see the device is online, the buttons are active. You can deactivate them one after the other, as you can see on the screen here. So you can see each button controlling each release and the relay turning off. All right, amazing. This is cool. So here you can see the input pins of the relays. Now we are going to be using an external power source using the SMPS instead of using the power bank to power it. So we want to power it directly from the NEPA or PCI lights to 40 volt AC. So it's going to step it down. As you can see now, the device is on. You can still do the same thing without damaging anything. As you can see, so this is the connection for the hardware. As you can see on the screen, the ESP32, the relay, the LCD, and so much more. Now we have the Raspberry programmed on the Raspbian Pi OS. So that's where we configure the Raspberry Pi and the USB camera. Also, the web app was built using Node.js Express on VS Code. Finally, the hardware was coded using the Arduino IDE, installing some libraries and dependencies to make it work. Right, here we are. This is the tablet. So we have, can see the time. This is 7:28, and we got the stream link for the Raspberry Pi. So we're going to go ahead and copy this and paste it on the platform. So you can see that is the string over there, that's me. And so now the next part is to control the appliances. So the appliances too are connected. As you can see, if you look up here, it says device 3F is online. So now on the app we can scroll down and then turn on one by one depending on the network that you're using. So just going to communicate, as you can see. Put on the next one. Okay, and you can see everything is on now, so we can put it off also. So we have that. I think this is just due to technical connection. Alright, so that's how the whole process is. You can view the camera. You can see there's Raspberry Pi there. You can see as I'm touching my hand, you can see it on the screen. Alright.